So, how is this possible? If you come from a language other than JavaScript, the notion of passing in a little beside that function is anathema to your standards, to what you know of language design, what you know of how functions should work. And yet here, totally fine. Totally fine for us to pass a function in as an input to be used inside of copy, array, and manipulate. We passed in a little multiply by 2 to be used under a new label instructions. It allowed us to make our function general, because we could leave it blank, we could leave it unspecified what instructions is going to be, what's going to happen to each individual element, and then fill it in only when we run copy, array, manipulate. How is this possible? In JavaScript, functions are what's called first-class objects. That means they have all the properties of objects, not they sort of have they are absolutely objects. They have one bonus property we'll see in a second, but otherwise they are absolutely just objects. And we know we can pass objects in to functions, no problem, perfectly standard. But we can also pass, therefore, functions that are just objects into functions. They can coexist with and be treated like any JavaScript object. They can be stored on variables. That's why you see var multiply by 2 equals and the definition of the function. They can be stored as properties of other objects, where they're known as methods. They can be passed as arguments, inputs into functions. And they can be returned as the return value. Here we returned an array, which by the way in JavaScript is also an object, but they can be returned as the return value. The function can be returned out as a return value from another function. And we'll see soon that gives us the most beautiful concept in JavaScript known as closure. Functions have one special property that objects don't have. Philip, what's the one thing they can have?
They can be invoked.
They can be invoked. You can put parens. I can't declare an object and then invoke it, but functions, despite being objects, have the ability to be invoked, to be called, to be run. And we're going to see that has consequences later on in our object-oriented programming, all to come. But for now, here's our question. This most profound concept, callbacks and higher order functions. I remember when I first encountered it, I thought, functions of a higher order. This most profound concept, we've seen it all. We've seen everything there is to see. So, which of these then is our higher order function and which is our callback function? One of these is our higher order function, one is our callback function. Skylar, which would you say is our higher order function?
Multiply by 2, because you're passing it in.
Philip?
Copy, array, and manipulate.
Copy, array, and manipulate is our higher order function. And then the little baby function that gets passed in, that's our callback function. Our higher order function is the outer function that takes in a function, or by the way, any function that returns out, any function that takes in or returns out a function, that host function is our higher order function. It's of a higher order, it can handle other functions being passed in and returned out. And then the function we pass in, multiply by 2, its placeholder was instructions, but multiply by 2 is a function, that's our callback function. So, callbacks and higher order functions, they simplify our code, they keep it dry. We no longer had to create copy array and add 3, copy array and multiply by 2, copy array and divide by 2. We built one general copy array and manipulate, and it had a placeholder for the specific thing we were going to do to the individual elements. And we can pass in, therefore, multiply by 2 as a function, or add 3 as a function, or divide by 2 as a function. We can pass those in, allowing us to have one general function, because I think all the code was the same. If you look back to copy array and multiply by 2, copy array and divide by 2, copy array and add 3, all the function code was the same. We had take an array, create a new empty array called output, loop through the input array, do something to each element, return out the full new output array, but all that code was the same. The only thing that changed was what did we do to each element. So leave a placeholder for that, and then pass in that specific instruction to do to each element only when we call copy array and manipulate. Pass in the specific functionality to do with the individual element multiple times in the for loop, only when we run copy array and manipulate. Pass in that specific functionality known as our callback function. So, callbacks and higher order functions simplify our code, they keep it dry. Don't repeat yourself. And they do something even more powerful that we're going to see later on. They let us run asynchronous code. And all that is to come later on.